good morning, good afternoon, everyone. My name is Denise Myrick, and I'm joined here today with Shiva Ravada, David Lepp, and Hans Wimman from the Oracle Spatial Technology team. We're really excited for today. We're going to have an overview of what happened at Oracle AI World 2025, and Shiva and David are going to give us their thoughts on some of the keynote speakers that we had and some of the demos that we went through. David, would you go to the next slide, please? So if this is your first time at a Spatial Ask Tom meeting, welcome. If you'd like to see some of our previous sessions, that QR code will direct you to our splash page under Ask Tom. And if you'd like to give us some ideas for future sessions, you can send emails to Karen and Hans, and we will work with you to get those sessions scheduled. If you have any questions for the Spatial team, we actively manage the Stack Overflow channel and also under Oracle forums. Any questions or posts that you tag as Spatial, we will be able to monitor those. So David, I'll send it over to you. Oh, and if you have any questions, please put them in the Zoom Q&A box, and we'll have people that are monitoring those there.
Awesome. And yep, so just stay tuned for our next session. Denise, there's always one more. There's always one more slide.
Always one more slide.
Yep. So our next one, and we're still debating on putting in our votes for what we want to present as a topic, and it's always welcome to get your feedback on that as well. So the next one will be the 25th. So as Denise said, we're going to give an overview here of AI World, the recently completed AI World, so from the spatial perspective, in terms of the big high-level messaging and how it relates to spatial, all the way down to some of the specific features and sessions and things that we talked about at a more grassroots level. And so the first thing that we were going to do is to give a overview, sort of an executive level overview of the big high level topics from keynotes. And just to make sure everyone is aware, the keynotes that we're going to be talking about are available on demand for anyone. If you go to oracle.com AI World and scroll down, there's a keynotes on demand section. And so if you just log in with your Oracle account, you're able to view them. And so Shiva is going to discuss the keynote from the keynote perspective. So Shiva, you can advance, I believe.
Yeah. Okay. Thanks, David. Hello, everyone. Good morning and welcome to the session. So as you can imagine, based on the name, there are a lot of AI questions throughout the conference, both at the demo booth and a lot of the sessions also. A lot of customers have questions about AI and how it relates to Oracle database. So in that context, Juan Luis's keynote really set the stage about how AI plays a role in the enterprise data environment. Everybody is worried about data privacy and not willing to give the data, expose the data to all of these LLMs and AI type of chatbots and those kind of things. So his keynote really set the stage about how AI can be used in the enterprise world. And I'll go through three main topics that he talked about on how to use AI in the enterprise world. But before that, the main announcement was that the Oracle database 23 AI has been now renamed to 26 AI. So unlike the past major database release versions, this is not really a major database version upgrade. It is just going to replace 23 AI with 26 AI. So from a customer point of view, customers will just apply the October DBRU for 26 AI, and then it's just treated like another patch set. So customers don't have to worry about doing all of the recertification, everything, which they typically do when there is a major database release. And the main reason for renaming the database version to 26 AI is to bring focus to the AI capabilities that are added into the database. So that's one of the main focus areas is AI, and how we have been adding a lot of the several AI capabilities in the previous DBRUs also. But with this DBRU, there are a lot of significant enhancements to AI. So that's why to focus on that aspect, it's been renamed to 26 AI. Okay. So the first point that Juan made was about architecting AI and data. So all of the enterprise customers have their data in the database, and LLMs are outside. So how do you combine the power of these LLMs with the enterprise data to make something meaningful for the enterprise world? So since we have this vector type in the database and also the vector search, now you can combine vector search to do typical LLM type of queries in the database. And you can also use the vector search to generate prompts or augment your prompt with more information and then send that information to LLM to do more meaningful searches. And because vector type is now a native database type, it also gives you the ability to combine the vector type with spatial and other graph types and other JSON and all of the other data types that we support in the database to provide a very powerful database engine that can leverage all of these AI capabilities. And then on top of that, there's a lot of work now going into RAG and how to enhance AI searches with using RAG. So we had a couple of sessions on how to enhance, use graphs to in the context of RAG. And we are also working on coming up with some examples to show how spatial context can be used to enable and enhance the RAG type of prompts. So in this context, basically, you can take a system prompt and use spatial searches and vector searches to enhance that prompt. Basically, kind of automated way of creating these RAGs and then using the RAG to do the LLM query. So just to narrow down the results that you get back from LLM and also to guide the LLM in the right direction. Because vector and spatial and graph, they're all part of the database. We can use all of these technologies now to create these RAGs and then use that to do the LLM searches. And then the other big feature that we have in the database is the Select AI. Select AI gives you the framework for taking the natural language query and then converting it to SQL and then executing the SQL. So Select AI provides a lot of framework and then gives you the ability to create the prompt and then send the metadata to the LLM and then be able to generate the SQL queries from the LLMs. So David will show some examples of how you can use the Select AI capability to also guide spatial queries. Again, you can take some natural language text and then be able to provide meaningful spatial queries and then build a workflow that actually does something meaningful for enterprise users. And one of the pain points for the database admins is always how do they deal with DBA type of problems. And one of the main thing that we are adding is the AI assistant for database administrators. And there is nothing specific to Spatial about it, but it's again a very useful tool for database administrators. And then the big thing that is included in this release is the annotations for AI. So if you looked at the previous DBRUs for 23, there is this concept of adding metadata for the tables and columns. Annotations takes it to the next level, so you can add more meaningful context for the tables. So this is more like a key value pairs that you can add. So you can add, if you want to add spatial context for the tables and the columns, you can very easily do that now with the annotations. And the way we use the annotations is to take the annotations and then build a prompt that we can send it to LLM when we convert the natural language to SQL. And since the spatial data tends to be complex, these annotations will really help describe the table and the data very meaningfully using key value pairs. And then that will really help the LLM come up with the right SQL for natural language to SQL type of queries. And then the next main focus is about what can we use, how can we use AI to generate code or to generate applications. One of the big problems with enterprise data is you don't want to use AI to generate low-level code that is very hard to maintain or very hard to debug. So again, customers also will not have any confidence when we use the LLMs to directly generate the code and run the code on your enterprise data. So that's why this concept of open app specifications that is developed around this idea that you can use the LLM to generate a specification, and then we will write compilers for that specification to generate the low-level code. So everybody is familiar with Apex. So Apex is now using this app generator specification to take the LLM natural language and use an LLM to generate a specification for the application the customer wants. So basically, customer will describe what the end application will look like, and then that thing LLM generates a specification for that description, and then Apex takes that specification and then using their own compiler will then generate the actual code to run that application. So that way customers will have some confidence about the end code that is generated because it is generated from the specification. So within Oracle now, a lot of the different groups are investing in the same kind of technology. So whenever you want to build an application, you can come up with a specification for what the end application looks like. And then natural language to specification happens through LLM. And then from LLM, from the specification to the code will happen through the compilers that we develop and we test and we make sure everything is correct. So we're going to use similar kind of concepts in Spatial Studio and other places as well. But again, this is still very early stages for this kind of thing, but that is the direction that we are going. And then the third main point is about combining all of these things and also opening up all of the capabilities of Oracle database to other data stores. So we have been going on this journey of separating the compute from the storage for the last couple of DBRUs for the 26th release. So now that becomes more of a reality. Now you can take the database engine, Oracle database engine, and then pull the data from other data stores. So if you, for example, if you have data stored as Apache Iceberg, then we can run Oracle SQL engine can run on the data that is stored in Apache Iceberg tables. So with respect to Spatial, Apache Iceberg also has a spatial data. So there is a standardization that is happening today to support spatial data as part of Apache Iceberg. So GeoParquet is one of the formats that can be used to store spatial data in Iceberg tables. So we currently already can read the GeoParquet files and then present the data as SDA geometry in the database. So we can directly read the Iceberg tables and run the spatial queries on these tables. So we still have a little bit more work to make this whole process automated, but we already have the capability to do the queries and those kind of things on the data stored in Apache Iceberg tables. And there is also this concept of catalog of catalogs, which I'll talk about on the next slide. So there was a new announcement to rename ADW to Autonomous AI Lakehouse. And one of the big reasons for doing that is now, again, the whole ecosystem is now opened up to data stored in other places. So you can store Parquet files in object store, or you can store Iceberg tables on other file systems or an object store. And now the Oracle engine can read all of the data and then do queries on top of that. This transition of a transanalytical, so you can take mission critical data, analytics data, and data science and everything, and you can, wherever the data is located, we can run the queries by pulling the data from that. So you don't have to really do an ETL to move the data into the Oracle database. You can leave the data where it is, whether it's in file systems or object store or wherever, and then Oracle engine can pull the data at runtime and then do the queries on top of that. So to make things faster, we added a few enhancements. So one is the data lake accelerators. So these are data lake accelerators, basically a bunch of VMs that come as part of the Oracle Autonomous AI database. And these VMs can be used to do filtering on the data that is coming from object store, for example. So that way you're doing most of the filtering on away from the database, closer to the data, and then the second level data comes into the database, and then you can do actual SQL analytics on top of that. And there is also a concept of Iceberg table caching. This is basically, you can think of it as like a database cache of the data that is stored outside the database. So if you have some frequently accessed tables in iceberg tables that are stored on object store, for example, you can ask the database to cache the data in the database itself. So then they become more native Oracle database tables, and you can run queries on them. Obviously, it's going to be much faster, so you'll get an order of magnitude improvement when you do that kind of caching. But again, that involves a data movement. So depending on the use case, you might want to cache some of those tables. And then there's also a project to do Select AI agents. So Select AI agents are built on top of Select AI to be able to automate all of this process of generating the prompts and then augmenting the prompts with some augmented retrieval with the data that is stored in the database. So today it's a very complex workflow that users have to build manually. So these Select AI agents will help streamline all of that process to make it easier. And then finally, AI data platform is another concept that is built on top of all of the database features that we provide. So it's not a separate thing. It's basically AI data platform can work on top of the autonomous AI database, but it's also do some other infrastructure pieces that Oracle is providing. So this is coming from the Oracle Analytics Cloud group. So they can take all of these data sources and then they can do higher level data enrichments and more agentic workflows, and those kind of things are built at the AI data platform level. So Oracle AI database is a part of the overall AI data platform level. But since we are part of the Oracle database, we are again working on making sure spatial data can be accessed in all of these workflows and in all of these scenarios. Whether the data is stored on files or object store or Parquet files or GeoParquet files or iceberg with Spatial, we will be able to run spatial queries on all of those situations. And then we're also working on providing these more AI-based tools to make the whole work, to be able to build the workflows and then enhance the prompts with spatial context and things like that. Okay. So that's basically on the keynotes. So it was, again, as I said, very AI focused. So a lot of the customers had a lot of questions about AI. So some of these keynotes tried to put some guardrails around AI to make the customers feel comfortable with using AI in the enterprise world. So that way we are not really exposing the private data to LLMs, but we are using some of the metadata that is part of the table descriptions and annotations to help LLMs come up with better answers for the questions. And then we had a few sessions. So I did one session with one of the customers from Europe called Enignum. So this customer is a big fan of Apex and Spatial. So they built this whole application using Apex and Spatial, basically. So they use all of the spatial features that we have in the autonomous database, including the geocoding and routing features. And then they use the spatial features embedded in Apex to build the mapping application. So the their product is basically do solar energy planning in Germany. So some of the local governments can buy their product and understand the solar potential for different regions within the country. And this is a very good example of combining AI with the traditional spatial technology and relational technology, and then geocoding and routing and all of the features that we have to make a very impactful application that's suitable for the customers. So they combined Apex, they combined OCI vision, and then spatial features in ADB, and then GPUs, the whole thing they were able to put together and build this solution. That's very useful for the customers. So David, you can take over from there.
Yep. Thank you, Shiva. And so the other spatial session that we had was delivered by our colleague Paul Parkinson, who is someone that we really suggest you taking a look at basically all the cool stuff he does. He's a developer advocate, sort of an architect in the database org, but his responsibility is to be kind of a mad scientist, assembling and integrating all of the coolest database capabilities with other platforms and developer toolkits and emerging sort of technologies. So he's always doing really cool stuff. And what we did together this year was this agentic system, agentic demonstration that was built to show a digital twin scenario. He actually called it a digital, instead of digital twin, digital triplet, in that it was meant to represent three different levels of representation of the digital representation of the physical world. And so those three levels were sort of centered on a factory floor, a digital twin of a factory. So in those two rows of the console, and the top row in the middle is an actual, sort of stop frame of this sort of animation of a factory with conveyor belts and things moving around. And there was the level of the factory, there was a level of individual parts that make up the machinery in there, and then there was the geospatial level. And so this demonstration was meant to show an agentic workflow that monitored the factory floor and the equipment and all of the sort of the condition of the moving parts with different sensors and so forth. And then when an agent detected some type of fault, the agentic workflow would take over and figure out which supplier would be best to get a replacement part from, and initiate that order. And of course, with a digital twin, it's all about sort of real-time data feeds and the way that they're all sort of integrated together to solve a real business problem. And those data feeds in this case were the factory floor itself. There was also a data feed from a partner of ours that monitors road conditions, because at the geospatial level, what we wanted to do was to incorporate those data feeds of road conditions and figure out which supplier was going to have the sort of the best logistics in terms of not having obstacles in transit to get a critical part to us as soon as possible. So that was sort of what was showed. And the role of Spatial in this case was to provide the endpoints and the resources for these agents to be able to figure out who should be the supplier to deliver us the part we need based on road conditions right now. So this is sort of what the whole front end uh, looked like. And of course, the factory floor was moving, and the digital twin of the road survey was sort of the car was moving, and you'd see the different road work and et cetera that was going on. And then on the bottom right, you'd actually see this map representation of conditions and routing from suppliers. So what I wanted to show here was behind the scenes in that demonstration. What was it that Spatial was doing to provide that resource to the agent in order to be able to have a sort of a restful natural language interface for the agent to be able to determine which supplier should be chosen for at any given point in time. So this is going to be a very quick walkthrough of what that looks like using Select AI that Shiva was talking about in this real scenario. Shiva talked about how with Select AI you provide some data, some metadata, data dictionary sort of information to inform the LLM about the actual table structure and how to build the query that's translated from natural language. And in this case, you can see that I'm building a profile that includes the facilities, so the factories, the supplier, and road obstructions, which are what are coming in constantly from this, basically from this IoT sort of supplier of real-time road conditions. So those are the objects that I want to inform the LLM about so that I can start to ask some natural language questions. So we're creating that AI profile, feeding that metadata to the LLM, and then we can start to do some basic natural language queries. Now, keeping this very simple just to get the point across. Uh, what I'm showing here as a first example is just Select AI, where I want to have the LLM build and run a query, and the prompt is simply, what is the best supplier in the most neutral, generic sense, where I'm also adding in that query sort of the instructions for how the LLM should behave with the following instructions. Well, first of all, it should use the 23, it's now 26 documentation to build the syntax of spatial queries. And when looking for the best supplier, what does that mean? It should be the supplier that has the shortest drive time and where its route is not going to go through a bunch of obstructions. And I'm actually telling it that I want the route for the best supplier to not be within 50 feet of any of these real-time road obstructions that come up along the way. So this is sort of priming the pump and telling the LLM how to behave when a question about picking a supplier comes up. So in this case, I just run the select AI and it's, literally just going to give me a result. This is the best supplier. Bit of a black box answer, but what's interesting is to show the SQL that was generated with that was behind that and take a look and see what the LLM did. So here we can see that the LLM was able to use the data dictionary information and select the supplier whose route is not within 50 feet of an obstruction. So the next thing that we had to do here was say, all right, I can get a meaningful spatial query from a natural language prompt with a little bit of system prompting. What the digital twin, what these agents were really going to do ultimately was they want to consume, they want to get back data in a standard format. The agent wants to get it back so it can be dropped into any open standard modern web mapping client that the console includes, which was MapLibre in this case. So what I want to get back when I ask a natural language question in this case is I want to get back a GeoJSON document because any client's going to be able to consume that result. So all I have to do in that case is I don't have to change I don't have to change my prompt. All I have to do is to give more system prompting. And one of the system prompts I added here was to say, always return a GeoJSON document to make this demonstration easier. So I want to return a GeoJSON document, and I'm going to tell it, what does that mean? Well, you're going to convert the geometries to GeoJSON, and you're going to assemble the entire result in a GeoJSON document. Here's the spec, and that's all I have to do in order to have the LLM go to that next mile of taking the result, converting everything to GeoJSON, and assembling a whole feature collection, as you can see here from the result. So same natural language prompt. The result now in this case is, as you can see here, is a GeoJSON document. Now, what we told the LLM when we pick a supplier, what we want is who's the supplier, how long is it going to take them to get there, and what's their path. And that just is what we told it to do. So here's what the result looks like from that same natural language query, but in this case with the result being GeoJSON that Paul's agents could just consume, visualize, put in a map, and initiate the next step of the process, which is to actually put in the order for the part. Then, of course, we could monitor where that vehicle is along its path and anything else we want to do. So the next thing I wanted to do is to see when we get that GeoJSON document, it's just cool to see how Select AI and the LLM is what type of query it's building. And you take a look here and you see that it's now assembled all these in-database JSON functions, JSON object, JSON array ag to build the document from the result set. Inside all that, it's converting the geometry to GeoJSON. And then, of course, in the heart of it, it's still making sure that the route is not within 50 feet of one of those real-time obstructions. And just, I think for all of us, it's really pretty cool to see how we just have to do the system prompting and then kind of evaluate the result, make sure it's behaving the way that we like, and sort of engineer those prompts. So the next thing that we had to do here was to and this is sort of when it comes to maybe tips and tricks, or not so much tips and tricks, but just explaining in a practical sense how you're really going to plug this into to an application that where you might want to specify different AI profiles from one query to the next. So when you're using Select AI, you're establishing an AI profile for the current session, the set of data dictionary information available to the LLM. And if you wanted to now do another Select AI statement using a different profile, you'd have to set a different profile. Instead, there's this function dbms cloud AI.generate where you set the profile, in other words, the set of data dictionary information at runtime for every query. So it's stateless instead of stateful. That's a very useful thing. And as you'll see, especially when you start to do this in a stateless environment like in ORDS or Apex, which is built on top of ORDS. So here I'm going to use DBMS AI Cloud Generate with the exact same prompt. And this time my question is, where are the driving obstructions? And of course, I want to get that back as GeoJSON, and I want to get used to how this function works. And you can see the difference here is that when you use DBMS AI Cloud Generate, it's a function. Not select AI is a select statement. This is a function, so everything's going to come back in one row, and that one row is going to be a JSON key and a JSON and then a value with all the results. In this case, the result itself is JSON. So what I need to do here is how do I extract the GeoJSON out from this key value result? And the way you do that is to simply use in database JSON function to extract this GeoJSON value from the result. So you can see that we can just run like a JSON table function to extract the GeoJSON out. And this is a little bit of a deeper sort of detail in the workflow here, but it's important once you actually want to plug this in and use it in terms of being able to ask these sorts of questions, extract out the GeoJSON like you can see I've done here, and get the result. So now when we take a look at what this result is, where our prompt was, where are the driving obstructions? Now we can see a GeoJSON document that is just a document of all of the road obstructions, the different potholes and roadworks, etc. And we can do a quick preview and see them. And this is exactly the set of obstructions that we saw in the screenshot of the console with the AI agents and so forth, showing us where obstructions are at any moment. What we then do, and like a reason why we do that, use that DBMS Cloud AI Generate instead of Select AI, is because when we want to do this in ORDS, to wrap all this as a REST API, because that's what the agent is actually calling. The agent is calling a REST API. We just drop that exact same query I just showed you into a ORDS definition, the handler for an ORDS REST endpoint, where the prompt is just a runtime parameter. So I have an endpoint, and then I can ask whatever question I want. I'm going to get back a GeoJSON document. In this case, it's GeoJSON because that's what I happen to pick. We could structure any format we want, and that will give us a result. So I could run this example, and here's a prompt like which is the best supplier, whatever natural language prompt I want. I'm going to get back a GeoJSON document like we can see here. And this is exactly the same sort of thing that we saw straight with SQL. Now here I can just run that REST endpoint, and this will mimic what an agent would be doing to communicate with our API through REST with a natural language prompt, get back a GeoJSON document that we could drop like Paul did right into the console. We see who's the best supplier, how long is it going to take for them to get there. So this was the it was a theater session this was the agentic AI and digital twin scenario, showing how natural language and select AI could really put the resources together for agents to do something in a sort of a somewhat of a real world type scenario where we're feeding from these real-time road condition feeds and figuring out the best logistics for a supplier to fix a part. So in addition to the sessions, we had a bunch of demos and some new feature stuff to talk about. The first thing I want to describe is actually builds directly upon what I just showed. So the thing that I just showed was Select AI and its sibling, DBMS AI Cloud Generate. I mean, they're sort of joined at the hip. Um, One is sort of stateful profile, the other stateless profile. But I showed that in the context of building a REST API for these agentic workflow. The other thing that we showed was how to use the exact same thing and just surface it in a simple Apex application to focus more on the mapping aspect. So the previous example was how to create a resource for agents, sort of API level resource. This is more probably maybe a little more intuitive. Just how do you have a natural language driven map? Essentially. So in this case, we do the same thing, but using some different data and different sorts of prompts and doing it in a map interface. So here I have a bunch of warehouses in blue and customers in green, and I configured this to answer questions about reachability, basically, not as the crow flies, but based on route drive time. So the first thing that we do here is just ask in natural language, what's the area reachable to one of these warehouses within a given amount of time, within 20 minutes. So here we see the drive time area. And just to reinforce that this is really a runtime thing, not just something that was pre-built or hardwired. We can just ad hoc change what that drive time is, and we're going to dynamically get the area of reachability. And again, based on natural language, so it's however someone would type this in. Now we want to know which of our customers are within that area, so we know who who amongst our demographic or amongst our customers, competitors, whoever are within given drive time. So how does that work? Well, it's very much the same as what I just showed a moment ago, except this time my profile is going to be based on these warehouses and customers. And then it's going to be really the same story around a user prompt, which is what's the area that can reach this warehouse within 30 minutes. Now my system prompts that are sort of my instructions, how the LLM should behave, are going to be, I know that this is going to have to do with reachability. And I want to first, make it clear what we mean by an area of reachability. What's a drive time polygon? Again, I'm going to point at the documentation, but now I'm also going to tell it that within the portfolio, the whole portfolio of Oracle Spatial and geocoding and routing, we have a couple different ways that can be done. One of them, and the newest and the easy way, is on autonomous database. We have hosted services, SQL functions that call hosted services, where all the backing data is in place. We maintain it. That's what I want to use. There are also functions that require the data to be that you sort of acquire and manage the data yourself, your own sort of institutional data. And there'd be no way for the LLM to know how I want it to behave. What should I want? What do I want it to use? Well, I'm going to tell it that if you're geocoding or routing or doing any of those sorts of things, I want to tell it use these elocation functions that use our hosted services, and here's how you should use them. And in this case, the vehicle, you should assume it's a car, so on and so forth. And so those are the system prompts that just help the LLM know how to behave and where to find information or what the spec is for our API. So here is the result of just asking that question. What's the reachable area within a given time? It's a geometry. It's just returning an SDO geometry. So that's fine. We can then take a look at the query that was generated, which is pretty cool because it's going to show that it's just running that elocation or eloc drive time polygon, 30-minute drive time based on a car driving. And now who are the customers that are within that area? So I've just added on to that prompt. And so now it's just giving me a tabular list. So these are the customers reachable to that area within a drive time. A quick pause for a moment. You remember in the previous one, I talked about, well, select AI versus DBMS AI Cloud Generate. Select AI is a select statement. You see we get a set of rows back because it's a select statement. DBMS AI Cloud Generate with the exact same prompt instead of giving us a set of rows like this, it'll give us one row, and that one row would be a JSON value with the key of customers and a value of like this whole set of customers, because it's a function that returns one row. That's just sort of looking back at what I showed before. I end up doing the same thing again when I want to do this in a stateless fashion in order to put this into an Apex app. So here's the result, and of course the SQL behind that result is going to do once again that eLocation drive time polygon, but then it's also going to wrap that with a point and polygon type any interact query to figure out which customers are in that area. So you can see there's the any interact to figure out which, so there's the drive time polygon, and then there's the customers and 30-minute drive time and which customers satisfy that any interact operator and are within that area. So like very cool again that it knows how to nest and combine these spatial operations with just a little bit of prompting. Now I can say I want the exact same thing, but I want it as a GeoJSON document. Once again, did this before. All I did was add the prompt to say, here's the spec for GeoJSON. Here's what a GeoJSON document looks like. And I can run that, and now lo and behold, I've got my drive time polygon returned as a GeoJSON document that I could consume from any client simply by telling it, here's the specification, here's where you find out what a GeoJSON document looks like. So now I can take that GeoJSON document like we previewed things before. I can sort of see what does this drive time area look like, do a quick preview, and this is VS Code with a mapping plugin. There's a plugin for everything in VS Code, and here's what our drive time polygon looks like, having been returned by Select AI. And now it's going to be the same story when we take a look at what the SQL is behind this GeoJSON document. It's going to be the same thing. The LLM knew how to invoke these in database JSON operations. List tag, it's it's assembling the outer tags and then building up the inner information, taking the drive time polygon, converting it to JSON, all that good stuff. And then that's literally just the Select AI bit. Then to go back to what I showed in Apex, the query behind that view that I showed is just now DBMS AI Cloud Generate, because I want it to be stateless. And for customers, it's the same thing. I'm doing the exact same thing that I just showed you in SQL, but with DBMS AI Cloud Generate, and then extracting the result out of it. So that's a quick fly through of a little bit of the natural language sort of stuff. And you're going to see a lot more of it, like Shiva alluded to. That's the kind of stuff that's now sort of we're starting to get the gears going of having that built into like Spatial Studio. It's going to be part of that Apex generative development sort of app dev language, and being able to just have maps be a sort of a first class participant in all of this sort of natural language flow. The other really important net new feature that we demonstrated and discussed at AIWorld is really a companion to a feature that we released maybe 6 months ago. So folks might recall that we released this get vector tile function. That's an in-database function that returns geometries as vector tiles, thereby simplifying the architecture in that you don't need a middle tier to do that geometry to vector tile conversion. We've done the same thing now for imagery, for actually any type of raster data. So the sort of the companion to get vector tile is now generally available and released on Autonomous, and it's get raster tile. So what get vector tile does for point lines and polygons, get raster tile does for any type of raster data, imagery, any type of gridded data. And of course, what it does is you specify the imagery or the raster that you want to serve as tiles. You specify that, and you specify the zoom, the X and the Y for a given tile, and it returns to you that tile. Now, just like with vector tiles, this is not meant to be used on a one-off basis of just asking for a specific tile. The whole purpose of this is as a developer resource to provide a service or endpoints that just stream data in the format, in the tiling scheme that all modern web mapping clients need. So the point here is to not we haven't done something new in defining what tiles are all about. All we've done is simplified the architecture to remove a whole tier of moving parts and sort of collapse it so that all you need is the database and a REST delivery mechanism like Oracle REST Data Services, which is all built in and built together to deliver all the content needed to web apps. And so here's what that looks like. So I have a raster table, Swiss Topo GOR, the raster for Switzerland. And just to show an example of running this function, I will say I want to get from one raster this particular tile, zoom level 12, the X and Y tile that I just specified. So at the level of that function, I get back a blob. And that blob is an image. It's just the bits of a PNG image. And here is the actual image. It's really blown up in this view, so it's sort of pixely looking here. But that is the image returned by that SQL function. So the way this is used is and I'll just to back this up for a second, the way that this is used, as I mentioned, is as a companion to get vector tile. So what get vector tile does with darn it, I misclicked. I apologize. My my video has gone rogue. I know what happened. I got into annotation mode. All right, sorry about that. All right, so just a quick rewind. So now I've showed how that SQL statement works. Now the way that these tiles are delivered are through an API that an application can call to get the vector and raster data needed for an application. And on the right is an existing one that I've had for a while, get vector tile. So an endpoint that invokes the get vector tile function to stream vector tiles to an app. And what we're adding now is the one on the left, the raster tiles, the same thing, but for imagery. So all we do to define an endpoint like this is to define the handler that will be run when a request is made. And so here's the request. Here's the SQL, underlying SQL that will be run when a request is made to this API. And you can see it's the same thing. It's the table, the raster, if I want to have a predicate that dictates exactly which image we want to stream tiles from. I've got a couple of additional values there, a couple parameters that have to do with how to treat missing data, whether those pixels should be transparent if there's no raster data, that type of thing. But then you can see there's placeholders for zoom, X, and Y. And those are the placeholders that are supplied at runtime dynamically by mapping clients when a layer is defined as having this endpoint be its source. So what this looks like, and I believe, yes, so we just basically, it's the same query and we're supplying runtime parameters of zoom, X, and Y. And here's what it looks like to invoke or call that API from a mapping client. So here you can see as the page renders, we have a couple things. We've got those red boundaries, which are municipalities, which are being streamed as vector tiles. And you can see each one of those calls in the network traffic down below is a call to both get the vector tiles and the raster tiles. It looks like that image you can see looks a little bit warped and twisted or something. You'll see why in a moment. And it's because that in this particular example, I've configured not 2, but 3 layers. There's, of course, the red boundaries, which are the municipalities, and there's the imagery that you can see. But this get raster tile is capable of serving any raster format. So whether it's actual imagery like this, or whether it's terrain or shaded relief, or whether it is an actual terrain model, a so-called terrain RGB, which is raster data that is then used as the terrain to drape other overlaying other layers on top of. And that's exactly what I'm doing kind of behind the scenes here. I've included a get raster tile endpoint for the terrain RGB and included it in this example. So as we roll forward here, we'll see if I click on one of these endpoints, this is one of the requests to get a vector tile for the municipalities. If I click on one of the ones like I've clicked on here, that's a request for getting the imagery, the mosaic, 2-meter mosaic with the zoom X and Y. These requests are all dynamically, automatically generated by the mapping client just based on my navigating and zooming and panning around. All that's in the client, in the code in JavaScript, is that signature of the endpoint. And just, because this includes a terrain RGB and this is a WebGL mapping client, you can tilt and rotate and do all that sort of 3D stuff basically for free, without any extra coding, without any extra anything. The clients are all natively capable of reading this sort of 3D format data, and the vectors, the municipal boundaries, all that sort of stuff, and the imagery all automatically drape. So the cool thing and the takeaway here is that like this stuff has all been possible to do, but had more moving parts, more tiers, more bits and components involved. And there's literally nothing here but autonomous database and JavaScript and HTML. And Oracle REST Data Services, which is all part of that, one of the tools that comes with ADB. So it's just a very, very simple architecture to allow you to get up and going really quick, leveraging the power of Spatial behind the scenes. And the very last thing that I wanted to mention in terms of things that we talked about and showed was that in our booth at AIWorld, we shared a booth with Spatial and Graph and Vector Search, and all three were really popular. People wanted to talk a lot about all of them, and it was really cool for us in the Spatial and Graph sort of group to really experience the enthusiasm and the interest and the curiosity that everyone has about all the cool stuff that can be done with vector embedding. I mean, Shiva talked a bunch about that and the ways that that's relevant to Spatial in a bunch of ways. It turns out to be like a really nice way to combine and sort of have a bridge between what we do in a basic sense with GeoRaster, and folks have heard about what we're doing with spatial AI. And with Oracle Spatial AI, we are adding a bunch of features for spatial AI deep learning on imagery to do things like object detection. So an example of what we're doing in spatial AI, which is part of Oracle machine learning on autonomous, part of what we're doing is being able to develop, train, and use models that would allow you to like take an image like you see here and say, count the boats. Like how many boats are in a particular area, or what is the exact detailed footprint outline of every one of the boats, of a very detailed, granular deep learning exercise. And that's the kind of stuff that we are releasing, but that's a pretty intensive, it's possible, but it really needs to be justified in terms of what you're really trying to get out of that exercise. And it turns out that if really what you want to do is to kind of profile an image and see, does something that I'm interested in exist in this image? And if so, kind of how pervasive is it and where generally is it in the image? And I don't need to go to the length of training a deep learning model and get GPUs and all that until I know that image is really a candidate because it sort of tends to have the kind of stuff I'm looking for. Well, the combination of GeoRaster and AI vector search is perfect in that context, because what we can do is we simply take the imagery of interest, like we see here, we tile it, and remember, we just talked about this new feature, get raster tile. So we've got the in-database functionality to automatically tile out an image based on whatever degree of resolution that we want. And then every one of those tiles can have vector embedding and stored in the native vector type in the database. And that turns this into a searchable image so that you could then take a little image clip of interest, like an image of some boats, and say, what are all the little chunks or tiles of this image, and where are the ones that are similar to this one, that have kind of the stuff that I'm looking for. And there may be, and that is a very straightforward, much less intensive exercise compared to getting GPUs and doing, developing and training and testing and validating a model and getting a very detailed result. That may be what you need, but this in one sense allows you to triage and profile the data to know that, yeah, this is where we should put our energy. And there may also be cases where this was really all we needed. We have some like much larger imagery, and we just kind of want to get a sense of generally where are the boats in this image, the boats or the oil tanks or the swimming pools or the road damage or the half torn off roofs or whatever it is. So this provides a really nice sort of midpoint or sort of option that is somewhere in between just sort of sitting there heads up looking through imagery on one extreme manually, and on the other extreme going the full deep learning route. This is a really nice sweet spot. So we'd really interested in seeing how people want to use this, and depending on how helpful people find it, the more that we'll actually turn this into more and more of a turnkey sort of thing and build features around it, as opposed to just having it be something that you can do with the platform as it exists. So we're coming up on the top of the hour. I want to just conclude with some resources, and of course, this deck will be shared. And hopefully, I wasn't monitoring the questions, but if there were any, hopefully they were answered. And we hope that this was a helpful summary of what went on in Las Vegas a couple weeks ago. So, Denise, I think I'll hand it back to you to sort of do the goodbyes for now, and if there's any questions that need to be answered.
Thanks, David. That was excellent. There were no questions in chat, so if you have any last minute questions, now's your time to type them in quickly. But as David has on the screen, there are a number of resources for you to go to, including the portal, our blogs, documentation. You can get to our webinar replays, the forum, and on-demand hands-on labs. If there's anything that we can do to make this a better experience for you, please let us know. And thank you so much. We'll see you at the next one. Yep, the resources can be posted on chat. David, since you have the PowerPoint, do you mind copying those links over?
Yeah, no problem.
Somebody's asking for a sample data set to play around with.
Oh, sample. One sec. Let me just copy this, and then yeah, there we go. So sample data set to play with. I think that the best thing to do. We really didn't talk about Spatial Studio in this session because there were all these other real big major topics to talk about. But a really easy way to get going with some sample data is to have Spatial Studio and go to something like, the Census Bureau, for example, or any of the thousands of places where you can download all kinds of shape files and load them with Spatial Studio and get up and going. I mean, that's part of what Spatial Studio is there for, to make it easy to just reach out and grab some open public data and uh, and load it to Oracle Spatial with a GUI and start playing with it and kicking the tires. And in fact, Spatial Studio allows you to do that both with point line polygon type data, loading from a shapefile or GeoJSON data that you can download like freely from gazillions of open public data sites. And it also allows you to load imagery data as well to GeoRaster. And that could actually be something that on another Ask Tom session, just we could actually do. Here's a little quick walkthrough of how you would go from scratch to grabbing some open public data, getting it loaded, and playing around with it.
It's a great idea. Okay, I think that was all the questions. So thank you all, and we'll see you next month. Happy Halloween.